Hi students, in this video I'll be going through the 2017 A Math paper 2 question 10. Alright, so this is a question regarding trigonometric equations as well as trigonometric graphs. Alright, so let's start by reading the question. So it's given that y1 is equals to 2 sine x plus 1 and y2 equals to negative cosine 2x. Right, so we need to do two things: state the amplitude and the period in degrees of A, y1 and B, y2. Alright, so let's do for y1 first. So y1, okay, so we will state the amplitude. Okay, so if you recall for a trigograph, the amplitude can be found simply by looking at the number in front of the trigonometric function. So in this case, the number in front of the trigonometric function is 2, right? Right, so the amplitude for the y1 would be 2, right? Okay, then next thing would be the period. Okay, so the period, if you recall, is the time taken to for one complete wave. Okay, that means for the sine graph, if you recall, sine graph will look something like this, right? Okay, so what is the time frame to have one complete wave from here to here? Okay, so how do we determine for the trigonometric graph, what will be the period? Okay, to determine the period is very easy. You just look at the number in front of the x. Okay, so over here is 2 sine x, right? So if there's no number, that means it's a 1. Okay, so if it's a 1, that means this is a usual curve. Okay, so for usual curve, the period is going to be 360 degrees. Okay, which means that from 0 degrees to 360 degrees, you will have one complete sine wave. Okay, so a sine wave looks like this. Okay, so the period for y1 would be 360. All right, let's do for y2 now. Okay, let's write down the amplitude. Okay, so for y2, the curve is negative cosine 2x. Okay, so in front of the trigo function is a negative 1, right? Okay, but when we are talking about amplitude, we are just interested about what is the difference in the distance between the rest point. Usually I call this the rest point, the center point of the graph. Okay, the center point of the graph and the highest point or the lowest point. So in this case, although over here is a negative 1, for amplitude, we only write the positive number. Okay, so you don't write negative 1, you just write 1, right? Okay, so later on when we sketch out the graph, then it's going to be quite clear now. Okay, what do I actually mean by this? Okay, then let's take the period for y2. Okay, so the period for y2. Okay, now the number in front of this x, right, is 2. Okay, so remember for period, we observe this number. Okay, so what does it mean by 2? Okay, if it's 2, right, it means that from 0 to 360 degrees, you will actually see 2 complete cosine curves. So if you recall cosine curve, okay, in this case, the negative cosine curve, okay, so negative cosine curve is going to be inverted, okay, inverted cosine curve. So you have one full curve, and then after that, one more full curve like this, right? So from here to here, okay, from here to here, actually this one should be slightly lower. Right, let me withdraw. Okay, over here. So from here to here, right, now it'll be 0 to 360. Okay, if it's 2, means you will get 2 complete waves. So you can see over here, from here to here, you have 1 complete wave, and then after that, you have your second complete wave. Okay, so if 0 to 360, you have 2 complete waves, then what will be the time for 1 complete wave? Okay, it will just be 180, right? Right? Okay, anyway, easy way to calculate the period would be you always take 360 degrees and then you divide by the number in front of x. So if the number in front of x is 2, right, then you will get 180. Right, so this will be the period for the cosine graph, right, y2. All right, let's move on to part 2. So they ask you for the interval x greater or equals to 0, less than or equals to 360. They want you to solve the equation y1 equals to y2. Okay, so y1 is 2 sine x plus 1, and then y2 is negative cosine 2x. Okay, so they want us to solve and find all the values of x that satisfies this equation for x between 0 and 360. Okay, so to solve a trigo equation, we need to try to convert this equation into a form whereby there's only one type of trigo function. Okay, so we either convert everything to sine or convert everything to cosine. Okay, so you see over here there's a double angle, right? So we can actually make use of the double angle formula. Okay, so cosine double angle formula, there's three forms. Okay, the first form will be cosine square x minus sine square x. Okay, then the second form will be 2 cosine square x minus 1. And the third form will be 1 minus 2 sine square x. Okay, so you've got to decide which form you want to use. Okay, so remember in this question, we want to convert everything to just one type of trigo function, right? Which is actually sine. Okay, so we will actually pick this third form, right? So let's do it. Okay, don't forget to put a bracket. Okay, minus cosine 2x. So this whole thing is cosine 2x, so we must put it inside the bracket. Okay, so we'll get this, all right? Okay, let's open the bracket. Okay, so we'll get negative 1 plus 2 sine square x. Right, so we're going to bring everything to one side. Okay, so if I bring everything to the right side, it's going to get 2 sine square x minus 2 sine x minus 2, right? Okay, so I'm going to rewrite this on the left side, okay, because I prefer the right side to be 0. Okay, so over here you can see it's quite obvious that we can divide 12 by 2 lah. Okay, so you get this. Okay, if you try to factorize this, you realize you can't factorize. Okay, anyway, I'm going to introduce a substitution to make this slightly more familiar to us. Let z equals to sine x. Okay, so the equation then becomes z squared minus z minus 1 equals to 0. Okay, so you realize that this one cannot be factorized, so we're going to use the quadratic formula. So minus b is now negative 1 plus minus square root b squared minus 4ac, right, over 2a. Okay, so over here you will get two answers. So 1 plus minus square root 1 square is 1 plus 4, you'll get 5 over 2. Okay, so in other words, z equals to 1 plus minus square root 5 over 2. So we're going to replace back with the sine x. Okay, remember what we want to find is sine. So sine x is going to be either this or sine x is going to be this, right? Okay, if you work this out with a calculator, it's going to be greater than 1. Okay, so we know that sine is opposite over hypotenuse. The opposite side cannot be greater than hypotenuse, so there'll be no solution for this side, right? So over here will be no solution. Okay, there'll be a solution for this side. Okay, so if you compute using your calculator, you'll get negative 0.61803. Okay, so we're going to find the basic angle first. So sine alpha. Okay, so let sine alpha equals to 0.61803. So alpha will be 38.17 degrees. Okay, then so since sine is negative, this is a negative, right? So we're going to go for the third and fourth quadrant. Okay, so in the third quadrant, x is going to be 180 plus the basic angle. Okay, and then in the fourth quadrant, it's going to be 360 minus the basic angle. Okay, so this answer is going to be 218.2 degrees and 321.8 degrees. Okay, so this to one decimal place. Right, so not too difficult of an equation to solve. Okay, but not exactly very short also. That's why it's actually a 4-mark question. All right. Okay, let's take a look at part 3. Okay, so part 3 we are asked to sketch the graph. Okay, so let me write out the equation over here. So the first graph is 2 sine x plus 1. Okay, then y2 is equals to negative cosine 2x. So we require to sketch these two graphs. So over here will be y, over here will be x. Okay, so my typical approach to sketching graphs is to set up the maximum point, the vertical shift, okay, which is also the I call it the rest point or the center point, as well as the minimum point. So minimum, vertical shift or center point, and the maximum. Okay, so let's try do it for y1 first. Okay, so y1 you can see that the vertical shift okay is 1. Okay, so that means this center part of the graph will be 1, right? Okay, and the amplitude is 2, so which means that the highest point is going to be 1 plus 2, you get 3. Okay, then the minimum point is going to be 1 minus 2, so you get -1, right? Okay, then now over here, the period is recall for this graph, the period is 360 degrees, right? Okay, so my approach is to use a ruler, okay? Make your points proportional. So maybe 360 degrees, you can put it at 8 cm. Okay, then maybe you can just put it somewhere over here. So measure around 8 cm. Okay, so 180 will be in the center. Okay, then after that, okay, so from 0 to 360, you have one complete wave for 2 sin x plus 1, right? So you need to divide the space into 4 equal parts, okay? Because there are actually 4 important points that you need to mark out. Okay, so I divide this over here. Okay, so for yourself, you can use a ruler to measure nicely, okay? So you can actually do like 2 cm, 2 cm, 2 cm, 2 cm. Okay, so let's mark out the 4 important points. So 90, 180, 270, and then 360. Okay, so the 4 important points. Okay, so if you recall for a positive sine graph, it goes like this. Okay, so over here we start from the center point of the rest point. Okay, then you go to the maximum point, then you go back to the center, the rest. Okay, then after that you go to the minimum, and then you go back to the rest point again. Okay, so remember this is the rest, okay, at 1. Okay, so for our graph, we're going to start here at 90, the first important point. Okay, so you use your ruler and go up properly. Okay, so okay, you go to the maximum. Okay, then at 180, go back to the rest. At 270, you go to the minimum. Then at 360, you go to the back to rest. Okay, I'm going to change the color of my pen. Okay, before drawing the graph. Okay, so let's use blue. Okay. Okay, so let's draw. Okay, you can draw nicely on the paper. Okay, on this computer is a bit hard to draw. Okay, so go here. So here, okay, and go here. Okay, so nice. Okay, this part I think I can make it slightly nicer. Okay, so the important thing is try to make your graph smooth now. Okay, so something like this. Okay, so the blue one will be y1. Okay, so let's call this y1. Okay, now let's do y2. Okay, so y2. Okay, let me go back to red to do the marking. Okay, so y2 is a cosine graph, and now the thing that changed is the period. Okay, and the amplitude. Okay, there's no vertical shift, which means that the rest point for the cosine graph is going to be the x-axis. Okay, the center point. Okay, so the amplitude is 1, which means that the maximum is 1, and the minimum will be at -1, right? Okay, so for negative cosine graph, okay, let's handle the period first. So the period will be 180 now, right? Okay, we got it from the earlier part, 81. So that means from 0 to 180, you need to divide into 4 equal parts already. So here to here. Okay, 4 equal parts. So here is going to be 45. Here is going to be 135. So from 0 to 180, you get one complete graph. Okay, this is a negative cosine graph, so it's going to be inverted of the cosine graph. So it's going to look like this, which means it's going to start from minimum, then go to the rest, then go to the maximum, then go to the rest, and then go to the minimum. Okay, so this is an inverted cosine graph, right? Because this is a negative cosine graph. Okay, the positive cosine graph will be like this. Okay, the positive cosine graph, remember we start from maximum. Okay, then go to rest, then go to minimum, then go to rest, then go to maximum. Okay, so this is a positive cosine graph. Okay, so now we want the negative cosine graph. Okay, so let's begin. Okay, let's draw the first cycle first. Okay, so we're going to start from minimum. Okay, negative cosine graph. then go to rest, then go to maximum, go back to rest, and then go to minimum. Okay, so let's draw. Okay, let's change the color maybe now to green. Just green. Okay, so let's draw. Okay, so this graph may be slightly easier to draw because it's smaller. Okay, so this is one cycle, right? Okay, so you can just continue for the second cycle. Okay, so this is what I mean by one complete graph within 0 to 180. Okay, so the next one, once you go to rest, okay, then the next point here will be 225. Okay, and then over here will be 315. Okay, so over here, going to go back after the minimum. Okay, go back to rest again. Go back to maximum, go to rest, and then go to minimum. All right, let's change back to green to draw the graph. Green, right? Okay, let's draw. Right, so this is the graph. Okay, so this green one will be y2. Okay, so this is how you draw the trigo graph, right? Right, so as you can see over here, there are two intersection points, right? Can you guess what is the value of this, the x value of these two intersection points? Okay, so you can actually get your answer from previous part. You see 218.2 and 321.8. Okay, so you can see actually it's quite accurate. Okay, this is just slightly before 225. So actually this one is the 218.2. Okay, remember just now you equated the two graphs together and you need to solve, right? Okay, then this one you see is just slightly further in front of 315. Your answer is 321.8. So your answer from the previous part actually agrees with the graph that you drew, right? Okay, so let's take a look at this next part of the question. Wait, let me change back the colors to this red. Okay, find the set of values of x for which y1 minus y2 is greater than 0. So y1 minus y2 is greater than 0. Okay, so if you think about this, right, if I shift the y2 to the right side, is y1 greater than y2? Okay, so basically this just means that they want you to write down the range of x for those regions whereby y1, which is the blue curve, is on top, is greater. Okay, so in this case, greater means on top, right? Okay, higher value, higher y value than the green curve. Okay, so you can see that the range of values are, okay, we can divide the graph into actually three parts. Over here, this is the first part, this one. So before this dotted line over this region, right? Okay, you can see that the blue curve, okay, y1 is on top of the green one. Then, so that we can divide this into another region. Okay, in this region, you can see it's not the case. Now the blue one is below the green one. So this is not the region that we want, right? Then after that, you can see within this region again, the blue one is now on top of the green one again. So these are the two regions that we want. Okay, this center one is not the one that we want. Okay, so all you need to do is just write down the range of x. So over here is 0, right? 0 degrees. Okay, so x greater or equal to 0 degree, but less than 218.2 degrees. Okay, so the range of x will be, okay, greater or equal, because we drew the graph okay, greater or equals, okay, for this, okay, over here. Okay, the range that we are given, okay, for the interval down here is the equal sign, right? Okay, x, okay, but this one less than 218.2. Okay, don't include the equal, because at the equal the blue and the green line are same value. Okay, but now they only want the blue line to be greater. Okay, over here is just greater only, right? So this is one range, and the other range would be x greater than 321.8, right? But less than or equals to 360. Okay, because we only drew until 360. Right, so I hope that this video has been clear enough to explain to you uh, what this question is about. Okay, so you can see O-level question actually not too difficult. Okay, you just have to understand the concepts well. But the nature of the question, the kind of things that they ask you to draw and solve is actually not too complicated.